Good morning, grade 4 girls. How are you today? Let's complete our lesson. How do scientists draw conclusion? Today is Monday, 13 April 2020. All of you open your books, Interactive Science, and open pages 325, 326, and write the date. Learning objectives. To know how scientists keep records in order to share conclusion. Before I start, I want to show you here a video. Did you remember the our experiment? It was we yesterday. I told you that we bring three different materials: carpet and rubber mat, and also wood surface. We throw the tennis ball on it. We bounce it, throw it on. We see the height of each ball. I will show you now the video.
My name is Mrs. Shanat from Skyview Elementary. In today's video, we will explore how to use tables, charts, and bar graphs, along with some tools and some really cool technology to organize, examine, and evaluate data. It is important to know this because recording and organizing data and communicating results are two important steps in any investigation. Whoa, look at all these balls bouncing. Reminds me of a student named Marcus in my class who wanted to compare different types of balls to see how high each one would bounce. So he completed an investigation to compare the bounce height of a baseball, a tennis ball, and a golf ball. Marcus constructed a table using computer software that helped organize his data. The table looks like this. The title of the table explains what information is contained in the table. The table shows the type of balls tested, the results of the experiment, and shows that the experiment was completed 3 times. That's called 3 trials. Marcus's next step was to display his data on a chart. There are a few different charts or graphs that can be used to display data. This one is called a line graph. A line graph is a useful tool to show trends or changes in data. This line graph shows the height that each ball bounced in each of the 3 trials. It uses multiple lines to represent each of the 3 balls. The horizontal line on the bottom is called the x-axis. It shows each of the trials. The vertical line on the left is called the y-axis. It shows the height the balls bounced during each trial in inches.
The x-axis.
The bounce heights are plotted at the corresponding data points along the grid. Another type of graph is a bar graph. A bar graph makes it easy to compare the data being presented and can present multiple data using different colored bars for each item. Bars can be either horizontal or vertical depending on the data being displayed. On this graph, again, the x-axis shows the trials, while the y-axis shows the height bounced in inches. The red bar, which represents the tennis ball, is the tallest. This means that the tennis ball bounced the highest in each of the 3 trials. In today's video, we explored how to use tables, charts, and bar graphs to organize, examine, and evaluate data. Conduct your own experiment. Hold a basketball in one hand and place a tennis ball on top of the basketball. Let go of both balls and measure how high the tennis ball bounces. Repeat the experiment 3 times and then graph your results.
The experiment 3 times.
Until next time, I'll be seeing you.
Okay, let's complete our lesson. Present data. Data using graphs. Okay. A paragraph uses rectangular bars to compare that data. You see here, this is trial number one, trial number two, trial number three. Type of surface, the black one, carpet, green, wood, and rubber. What is a graph? It's a drawing that shows information. Presenting data. There are many different formats for organizing and arranging your data. The table on the previous page is one format. Charts and graphs can also be helpful because they show information in a way that is easy to understand. However, you format your data, it should be clearly labeled. Paragraph. As I show you in the previous slide, a paragraph uses rectangular bars. Here, rectangular bars to compare data. The bars may be vertical or horizontal. The bars have different colors or shading for each variable. Now, who can read for us question number 4? Conclude. In the paragraph shown here, what would happen if color key was missing? This is the color key. If it was missing, here is it. Color key. You see where is the arrow here? You would not be able to tell which part stands for which piece of information. As example here, the red for wood, the green for carpet, the blue for rubber. This is a line graph. This is a line graph. Here the x-axis and here the y-axis. Line graph connect points of that data on graph with straight lines. Suppose you want to show how fast or slow a runner traveled over the course of 2 hour race. Which type of graph would you choose? Who can tell me the answer? Okay, excellent. 2 points for you in Class Dojo. I would choose a line graph because a line graph can easily show patterns of data over time. Line graph, as I told you, connect points of the data, a graph with straight lines. You see here, connect. This is here points, connect points, okay, with straight lines. Line graphs are often used to show patterns for data over time. For example, a line graph could show the amount of rainfall place a place get over 2 weeks. A graph uses different color lines to compare different data. Express data. Work with a partner to write one or two sentence explanation for the data in the line graph. Read your explanation. It rained a lot on one day during this 2 week period. Other days received little or no rain. Other days received little or no rain. Inferences and answers. Scientists use prior knowledge and data to draw inferences or conclusions that help answer questions. Here winter and it's summer. So, as I told you, what is the meaning of inferences? Is a conclusion drawn from that data and observation. For example, the statement the tree has no leaves on its an observation. The tree lost its leaves because the season is fall. It's an inference. Okay, now infer. Make an inference about which of the balls below will bounce highest on wood. I think the rubber ball will bounce the highest. The rubber ball will bounce the highest. Now, question number 7, justify. What evidence supports your inference? Who can tell me the answer? Yes, excellent. I have played with each kind of ball, and the rubber ball bounced higher than the other. Look at this picture here and answer the question. Someone noticed that a tree had no leaves and inferred that it lost its leaves because the season was fall. Write another reasonable inference based on the observation. The tree had a disease. The tree is dead. So maybe the tree had a disease. The tree is dead. Okay, thank you, my dear student, for your listening. And tomorrow we will complete our lesson, inshallah.